Hi everyone, my name is Khalif bin Khairul and I'm here to explain to you on the introduction for our group project for the subject Fundamental of Digital Competence for this semester. Right, so in this video, it's quite simple actually. We are going to fill you in with three important things. The first is the Innovation Technology Lifecycle poster, which is actually mainly focused on the Winston model for our electric vehicles to combat carbon footprints. The second thing is we're going to explain to you on the C++ program that we have created ourselves in order for customers to buy and purchase their own electric vehicles based on their preferences. And number three, the last one in this video is the mockup visual and user interface that users will actually see when they use the app. All of these include several references and additional information explained by my fellow teammates, and hopefully this will be an informative watch for the viewers watching this video. Hope you enjoy.
Hi, good evening everyone. Today I will be explaining about our Winston model on reducing carbon footprint using electric vehicle. The Winston model explains how a technology evolved by looking at both technological development and social influences. It helps us understand why an innovation was created, how it developed over time, and how it affects society. I will begin by explaining the background and the early stages of electric vehicle development. The first stage is supervening social necessity, which refers to the social problem that created the need for electric vehicle. In the late 1800s, horse-drawn transportation caused serious environmental problems, especially pollution from horse waste in growing cities. Later, during the 1973 oil embargo, oil prices increased significantly, making people realize the risk of relying heavily on fossil fuels. At the same time, public awareness about environmental protection and air pollution also increased. As a result, society began looking for a cleaner and more sustainable form of transportation. This factor created the demand for electric vehicles. However, despite this growing need, electric vehicles did not become popular immediately. This stage is known as the low suppression of radical potential. The discovery of large oil reserves made gasoline much cheaper, while the number of gas stations increased rapidly. In addition, Ford's mass production of gasoline-powered vehicle made internal combustion engine or ICE vehicle much more affordable. The invention of the electric starter also made gasoline car easier to use, removing the inconvenience of hand cranking. Because of this development, interest in electric vehicle declined for many decades as gasoline car became the preferred choice. Although electric vehicles become less popular, scientific research continued to improve the technology. Scientists and engineers developed better electrical machines, improved battery technology, and more efficient electric motors. Other important innovations such as regenerative braking also increased vehicle efficiency by recovering energy during braking. Continuous research in batteries and charging technologies laid the scientific foundation for the modern electric vehicle we see today. With this scientific advancement, the idea of electric vehicle continued to develop. Inventors such as Anios Jedlik, Sibrandus Strating, and Robert Anderson introduced some of the earliest electric vehicle concepts. Their invention demonstrated that electricity could be used as a practical source of transportation. Although these early models were simple, they inspired future development and encouraged further innovation in battery system, electric motors, and hybrid technology. The next stage is prototype, where these ideas were transformed into working design. One of the earliest examples was Jedlik's electric car model in 1828, followed by Strating's model in 1835. Robert Anderson also developed one of the first electric carriages during the 1830s. Later, early commercial prototypes were introduced, including Porsche's early electric and hybrid vehicle, such as the Sempervivers. This prototype proved that electric vehicles were technically possible and prepared the way for future commercial production.
The innovation stage is where the prototype become real vehicles. Anderson built the first electric carriage and the Electrobot became the first commercial EV. Porsche developed the EV hub motor vehicle, followed by the Semmelweis, the world's first functioning hybrid. Richard's 100-mile electric automobile proved EVs could cover real distance. In the modern era, the GM EV1, Toyota Prius, Tesla VW Cedric, and Toyota Concept I brought EVs to the mainstream. Diffusion is when EVs spread widely across society, from personal car and electric taxis to trams, trolley buses, and electric buses. The Lunar rover even took EVs to space. Autonomous EVs like the VW Cedric and AI integrated vehicle like Toyota Concept I merge EVs with the advanced technology. Charging infrastructure expand globally and government begin phasing out the ICE vehicles, showing diffusion is technological and social and also the political. EV development created major spin-off technologies. Battery advanced from lead acid to lithium ion. Hybrid vehicle emerged as a transition technology, and regenerative braking becomes standard. Charging network grew into the global industry. AI integration and the shift toward the autonomous vehicle are ongoing spin-offs that continue to expand EV impact across multiple industries. Redundancies are the update needed to keep EVs from becoming obsolete. Battery efficiency, driving range, performance, and charging speed must keep improving. New vehicle types, hybrid and fully electric car and vans, ensure EVs remain relevant across different markets. Innovation is never finished. Technology must keep evolving. The performance axis shows that what EVs deliver to society: lower operation costs, higher energy efficiency, and significantly reduced carbon emissions. This directly addresses the social and environmental needs that original drove EV development, proving EVs are successful and impactful innovation. The future of EVs is low carbon and environmentally friendly transportation system. As a government pays out ICE vehicles and charging infrastructure expand globally, EV will become the standard, and AI, autonomous driving, and digital connectivity will make future EVs smarter, more efficient. A future shaped by the nearly 2 centuries of scientifically and social progress. To conclude, the Winston model traces the full life cycle electric vehicle from early science and ideation through the innovation and diffusion, shaped by the social necessity, suppress the ICE dominance. Today, EVs are no longer the future, they are the present. The development was driven not just the technology, but by the genuine needs of society. Thank you.
Hello and Assalamualaikum. My name is Nuri Nazar, and today I'll be explaining my part of the coding, which is input part of the coding, and we'll be using W3 School coding website as the main reference. To start, we have include IOStream on line 2, which is the header file library that lets us work with input and output objects. On line 3, we are using namespace std semicolon. It's basically to not constantly repeating std semicolon on every start of cout or statement, so that the coding will be a lot more cleaner and readable. And semicolon is needed to be put at every statement, at the end of every statement, so that this can tell the compiler to basically know that this is the end of the statement. So line 4, we are putting space, even though the space is included. On the output side, it will not be count as a space. Instead, the space in the input is just a space where we used as way to make the coding more easy to read for the coders. On line 5, we have int main, which can be only written once. The function serves as entry point for C++ program. We also have curly bracket on the code to start the coding statement. Line 6, we have cout less than symbols. This is where every statement that starts with quotation will be included in the output side of the coding. So there we have hello there, welcome to Drive for Tomorrow. This is where every single part of them is basically will be shown in the output. And then we have n double backslash n in a quotation and semicolon. Backslash n is basically used to put a vertical space on the program coding, and like we said, we use semicolon at the end of every statement. There we have it. And then another space on line 7, and on line 8 we have double forward slash ask users for input. This is where the coders sectioned the program so that it's more readable and clean for coders to see mistakes, or even for coders to put like description on it, like it says there as users. On the line 49 we have default, where cout will be given invalid choice, please select 1 until 4. This is where if the users put none of the given input that is predicted, so it will give invalid choice. So let them select between 1 until 4. And then we put curly bracket there twice for 50 and 51, line 50 and 51. So on line 54 we use else if. So basically concern equals to 2 is basically concern equals to true statement, which is a vehicle type. So you can see that else if is constantly used on between section, which is daily use, vehicle type, and also user's choice. However, on user's choice we use if, because user's choice is the first concern, is the first input. So the rest will be using else if, which is the truth, however on the second and third, or even more. And then on line 55 until line 61 is the same concept, and line 63 until 70 is the same concept also. And then lastly, for else, which is on line 98, we put cout cout less than symbols, and also invalid choice. So on line 98 we have else, which is used when the given input is invalid or not the truth, which is, for example, we have budget number 1, vehicle type number 2, and for daily use number 3. So if the users given the input of 4 or 5 or more, they will show invalid concern choice on the output. And then lastly we put return on before that we have line 102, we have backslash and until backslash and also. This will give the segmentation and will be shown in the actual output. And lastly, on line 106, we put return 0 semicolon and we close the whole statement and the whole coding with curly bracket on the line of 107. That's all from me. Thank you.
Hi, my name is Alisa Ameh. I will be presenting the output of our coding. Based on the input entered earlier, this is the summarized output generated by the system. In step 1, the user entered their name to begin. This creates a more personalized experience. For example, I entered my name, Alisa. So the system greets me with Hi Alisa. In step 2, the user chooses their main concern when selecting a car. There are 3 options: budget, vehicle type, and daily usage. For this example, I selected option 1, budget. The system then displays the corresponding option for the selected category. In step 3, I choose the 150k to 200k ringgit budget range, which fall under the mid-range category. Based on my selection, the system generates personalized recommendation. In this case, it recommends the BYD Seal and Tesla Model 3. Moving on to the next slides, this shows the output when option 2, vehicle type, is selected. The user can choose their preferred vehicle type such as sedan, SUV or hatchback. I selected SUV and the system recommends the BYD Atto 3, Audi Q8 e-tron and Mercedes-Benz EQ8. Lastly, if the user select option 3, daily usage, the system asks how the car will be used. I choose daily commutes. And the recommend vehicle are the Aura Good Cat and BYD Seal. Overall, the system provides recommendations based on the user preferences, making the car selection process simpler and more personalized.
Hello madam, my name is Nivisha PM Sundar and my student ID is 261UG245WF. For my section, I'll be presenting the mockup visual and user interface for our program, which is called Drive for Tomorrow. So this mockup was created based on our C++ program flow, and it represents an electric vehicle EV recommendation assistance system that helps users make better electric vehicle purchasing decision easily. Now moving on the mockup design, the interface is simple and user-friendly. Users will first be greeted and asked to enter their name, and they will choose their main concern like budget, vehicle type, or daily use, and the program will guide them step by step until they receive their personalized EV recommendation. Finally, in terms of key features, Drive for Tomorrow clearly displays EV options based on user input and automatically filters results according to their selected concerns and ends with an encouraging message to support a greener future. Now overall, the design is clean and straightforward, making it accessible for all the users. That's all from me. Thank you.
With that being said, thank you so much to all of my respective teammates and their contribution in this video. We start off with the Winston model, who was introduced by my fellow teammate Irfan and Pavitra. They explained about the evolution and the development of electric vehicles throughout the century, starting with the performance, supervening, social necessity, the laws, the prototypes, and so on and so forth. We move on to the C++ program, which was explained by Noreen and Alisa. They both explained thorough detail about the inputs and the outputs. They also showed and displayed the examples of the outputs, for example, budgets, the vehicle type, and also the daily use like commuting or family use. We ended off with Nivisha, who explained about the markup visual and interface, which had 4 different interfaces that can show what the users will actually see if they were to use our app. With all that and much more, we hope that this video has been very informative to the viewers, and we believe that the Winston model is an important way for us to know and be more informative about the development of any technology advancements right now or maybe in the future. We believe that this video can hopefully be a reminder for all future generations to know and be more aware of the type of advancements that these technologies may have. And with that, thank you so much for watching this video.